Okay, we are live. Uh, just a heads up to anyone that is watching this either live or later when it's uploaded on the channel. I'm 2 beers in, so I'm doing this. I'm doing this video, this stream a bit tipsy. Hopefully, it won't be a detriment to the quality of the experience we will have. Uh, I mean, it will. I barely understood uh, anything we were working on when I was sober as fuck, and now doing it under influence. Maybe maybe I maybe it turns out that beer is like the limitless pill for me, and I became ultra intelligent because of it. Okay, without further ado, let's do this. If you remember, in the last episode, I think we started with chapter 7 and we skipped a couple of sub chapters, but I just wanted to go back to make sure that I understood everything properly. Oh, my tablet went off. By the way, do you like my new wallpaper? It's a cat holding a katana. Okay, without further ado, let's start. Let's start. Let's start. Let's start. Just a second. I'm just testing to see if everything is all right. Seems like this. Okay. Chapter 7, evaluation. Let me just move my tablet somewhere where it's more, where I can have better visibility. Maybe here. Maybe here. Yeah, good place. Okay, so what we did, let me also show this as well. It's here. It's the parser.c file. So we actually did quite a lot of initial setting up. Here we have the directive to check if we are using Windows or not. I'm gonna skip the Windows part. We are starting officially from here. So inside of the main, we are using the MPC library to create our language. All of this is setting up our new language. Next, we are reading our input and we are parsing the input that we write in, and we are checking it against the language that we created, right? Yeah, here. If the input is parsed, if it's the language, we are, I think, just printing it out now. Okay, let's continue with work. Okay, we can read input and we have structured it internally, but we are still unable to evaluate it. In this chapter, we add the code that evaluates the structure and actually performs the computations encoded within. If I'm not mistaken, we already did this, so we are just coming back. We are relearning the evaluation procedure. Okay, so the internal structures what we saw printed out by the program in the previous chapter. It's called an abstract syntax tree. Okay. And it represents, so what is the abstract syntax tree? It represents the structure of the program based on the input entered by the user. At the leaves of this tree are numbers and operators, the actual data to be processed. At the branches are the rules used to produce this part of the tree, the information on how to traverse and evaluate it. So in layman terms, I assume that the abstract syntax tree is nothing more than a representation of a language, a visual representation that looks like a tree in which the nodes, the leaves, are actually the lowest rules of the language, and the branches are rules that can be branched out further. I'll just double check it. I have the ChatGPT here. I like using ChatGPT. Okay. Quick. Abstract syntax tree. What is it? Simply explained. Okay. Okay, an abstract syntax tree is a tree-like data structure used to represent the structure of code in a hierarchical manner. Yeah, it's called abstract because it represents the logical structure of the code rather than its exact syntax. Here's a simple breakdown. In an AST, each node represents a construct occurring in the source code. This code could be an expression, a statement, or a program block. Then we have the hierarchy, abstraction, we have some use cases. Okay, a simplistic example is the best way to learn, in my opinion, because once we can visually represent and give us an example, the most basic structure of what we are trying to learn or solve, then we can build upon it and create more complex data structure. So, like, look at this. This is like a pretty simple example. So we have an expression like this, and the abstract search tree would show plus as the root node, as A is one child, and the multiplication as another child, and then this node would have this. Okay. Let's come back to it. Before working out exactly how we are going to do this traversal, let's see exactly how this structure is defined internally. If we peek inside mpc.h, we can have a look at the definition of MPC abstract search tree ._t, which is a data structure we got from the parse. Okay, I also remove this. So this is struct, right? mpc.h. It's quite a big file. Where are you? This is the error structure. This is the union structure. Where is the abstract search tree? Where are you, fucker? Ah, okay. So what we have? We have a number of fields here. We have tag. So what is the tag? When we printed out a tree, this was the information that preceded the contents of the node. Okay. It was a string containing a list of all the rules used to parse that particular item. For example, expression, number, regex. The first field is the tag. When we printed out the tree, this was the information that preceded the contents of the node. Let me just double check it. Clear parser. I forgot 4, 2, 5. Is this working? Yeah. So what I assume the tag is that preceded the contents of the node. It's a list of all the rules used to parse this particular item. So in this case, it's this one. And it builds upon and it derives directly from the code that we were, from the language that we created here. So cat parser.c, it derives the logic from here, right? Yeah. So MPC new number, MPC new operator. Okay, I also need to, let me just go back to the tablet. Create a macro for, I forgot what I wrote here. Create a macro for terminal. To increase it to 220 size. Okay. We'll do this, but first of all, please check the way language is created again. Okay. Check. I just want to know it. I want to understand it really good. I still have some holes. I still have some fog in the way I understand it. So I want to have the full grasp. Okay. Okay, let's continue reading this. Okay, the tag field is gonna be important as it lets us see what parse rule have been used to create this node. Tag field, parse rules. Okay. The second field is contents. This will contain the actual contents of the node, such as the asterisk, the opening braces, or 5. And you'll notice for branches, this is empty, but for leaves, we can use it to find the operators to use. So what is the content here? In this case, is this? Yeah, is this? So this is the tag, and these are the contents. And the next field is state. This contains information about what state the parser was in when it found this node, such as the line and column number. We won't make any use of this. Finally, we see two fields that are going to help us traverse the tree. So children, right? Children, and what else? Childrenum, right? Okay, the type of the children field is MPC. MPC abstract search tree, which is a pointer to a pointer. It isn't as scary as it looks, and it will be explained. Okay. Can you explain me how a double pointer works, and can you give a simple example to follow it? Okay. A double pointer is a pointer that points to another pointer. Makes sense. This concept can be a bit tricky at first, but it's very useful in programming, especially when dealing with dynamic memory allocation, complex data structures, or passing references to pointers in functions. Here's a simple explanation example to help you understand double pointers. Okay. I already know what a pointer is. It's a variable that stores the memory address of another variable. For example, if int asterisk p is a pointer to an integer, p holds the address of an integer variable. A double pointer is a pointer that holds the address of another pointer. Okay. A double pointer, you have two levels of indirection. The first dereference gives you the address of a pointer, and the second gives you the value stored in the pointer being pointed to. Man, C is some mess. It's a really weird language because looking from a, I don't know, from the layman's perspective, it seems pretty simple. It seems like a simple language, and then you come in and there's memory allocation, and there are pointers, references, double references, dereferencing, and a garbage collection, and you know, a lot of these things are most probably pretty easy once you gain some experience in the language. But for me, by the way, I'm a front-end developer, so I'm double stupid. Okay, sorry. A normal integer variable. It's a. Sorry. It's a. Assigning the value 10. Okay, then we have a pointer p pointing to a. Pointing to a. So this is most probably holding the address of the variable a. And then we have the double p, which points to this p. So, okay, let me guess. I'll try to solve this without looking at the solutions here. Value of a is 10, right? Come on, will you print it out? Ah, here it is. So value of a is 10. Value at p is the address value, right? No, it's 10. Why the fuck is it 10? Value pointed by p, which is a. Value pointed by pp, dereferencing twice to get a. Okay. Address of a. So this is how we get the address. Ah, okay. Ah, okay. So, okay, I think I get it. So this is the value, not of the memory address, this is the value of the value a. Because am I dereferencing it here? Right? Yeah, I am. But if I only print out p, then I'm going after the address. And value of pp. The value of pp, okay. Okay. I still haven't understood it, but every time I relearn it, it makes it a bit simpler. We can access a child node by accessing this field using array notation. This is done by writing the field name children and suffixing it with square brackets containing the index of the child to access. For example, to access the first child of the node, we can use children 0. Notice that C counts. Okay, easy. Okay. So what do I have here? I'm loading the abstract search tree from output. Okay. So what do I want to print out? I want to print out, let's print out the tag. Okay. So it says T. My computer is burning, by the way. My laptop is freaking burning. Wow. It's so hot. Shh. Okay. AST tag. This. I need to rebuild it. Why? Ah, okay. I think I know why I get this error. Because I'm trying to run the. Why the fuck? Delete it. Okay. I don't need this. How do I remove a single line? How to remove a single line in Vim? I think it's D, right? DD, yeah. Okay. I don't know. +25. Segmentation fault core dump. Ah! Why the fuck? Why the fuck? Why the fuck am I getting a segmentation fault? Unused variable AST. Okay, let's first read through the book and then we will work. Okay, this is something that I'll definitely come back to. There's another thing about this tree structure. It refers to itself. Each of its children are themselves trees again, and the children of those children are trees yet again. Okay, just like our languages and rewrite rules, the entity structure contains repeated substructures. Recursion, one of the most important concepts in programming, even though you might never use it once, you know, once you have a grasp of it, and once you learn it either in university or on a side project, you might never use it. I think I maybe used it 4 or 5 times in total. Put simply, a recursive function is one that calls itself at, and these 4 or 5 times could have been solved just using, I don't know, regular loops or something, but I wanted to act smart, so I used a recursion. It calls itself. It looks weird for a function. As an example, we can write a recursive function which will count the number of nodes in our tree structure. To begin, we work out how it will act in the most simple case. If the input tree has no children, in this case, we know that okay, yeah. So we have the, okay, where are you? We have the abstract search tree, and if the children num is 0, then we return only 1. Otherwise, if it's bigger or equal than 1, okay, okay, let me just go through it. So if it's bigger or equal, sorry, bigger and equal than 1, bigger and equal than 1, the total is 1, and then for each children num, I have the total, and the total is total plus number of nodes, and then we return the total. Okay. Yeah, actually, this is correct. The good thing about recursion is that once you understand it, it's quite simple to work with it, and it follows the same pattern. You know, you have the base case, and then you have all the other cases that should, in the end, trickle down to the base case itself. Fuck. To evaluate the parse tree, we are going to write a recursive function, but before we get started, let's try and see what observations we can make about the structure of the tree we get as an input. Try printing out some expressions using the program from the previous chapter. Okay. Unused variable ast cat. Is this guy, right? Yeah, it's this guy. Then parser.c is here. How do I write comments? Is it like this? It is like this. Will it work now? It will. Okay, so this 151. We have the exact same input as in the book. One observation is that if a node is tagged with number, okay, like we have it here and here, it is always a number, has no children, and we can just convert the contents to an integer. This will act as the base case in our recursion. If a node is tagged with expression and is not a number, we need to look at its second child. The first child is always an open brace, and see which operator it is. Then we need to apply this operator to the evaluation of the remaining children, excluding the final child, which is always the closing brace. This is our recursive case. This also needs to be done for the root node. Okay. Now we're gonna write some code. Okay. When we evaluate our tree, just like when counting the nodes, we'll need to accumulate the result. To represent this result, we'll use the C-type long. Okay. To detect the tag of a node, or to get a number from a node, to detect the tag of a node or to get a number from a node, we need to make use of the tag and contents field. Okay. These are string fields, so we are going to have to learn a couple of string functions. This function will convert a character pointer to a long. String compare takes an input two characters, and if they are equal to 0, okay. String takes as input two character pointers and returns a pointer to the location of the second in the first, or 0 if the second is not a substring of the first. String substring, okay. String substring. We can use string compare to check which operator to use, and string substring to check if a tag contains some substring. Altogether, our recursive evaluation function looks like this. Okay, let's write it. Vim parser.c. So where should I write this function? Let me ask ChatGPT where to write helper methods in C. Can I write them inside main? In C programming, helper methods or functions are typically written outside the main function to maintain code organization, reusability, and readability. Here's an explanation where to write helper. Okay, so it's outside the main. Good thing to know. Good thing to know. It's here, right? It's here. Let's start. me just do it like this. Will this work? Will this work? That's... No, I need to turn it the other way. Okay, maybe this. So long MPC T if string substring, if the tag is a number, if a tag is a number, oops, the contents. Okay. The operator is always second child. Why is the operator always the second child? Why is the operator always the second child? No, I'll leave it like this. Output. Okay, words of advice. Don't work. Don't try to work when you are drunk. I know what you're thinking. He's keeping the illusion of composure, but I'm not. I basically don't understand anything that I'm writing here. No, it's not chat. It's char. Character. OP. Children. E++, and then I have here turn X. Okay. And we have the other method which called evaluation operator. It takes a number as an operator and another number. It tests for which operator is passed in and performs the corresponding C operation. So it's long evaluator operator. So I'm getting the X, getting the operator, I'm getting this. So what I'm providing here, I'm providing the X. What the fuck is the X, man? So if string compare, I have the operator, and the operator is a plus, and if it's 0, return x plus y. Ooh, now I can find another good use of Vim. How to copy a line in Vim. Why? Open your file in Vim, navigate to the, okay. So if I do this, what? Ah, it's P, right? Another one, another one. How to replace a character in Vim. Navigate to the character you want to replace. And the book says now, instead of printing the tree, we now want to print the results of the evaluation. Therefore, we need to pass the tree into our evaluation function and print the results we get using printf and the specifier. Okay. We also need to remember to delete the output tree after we are done evaluating it. If all of this is successful, you should be able to do some basic maths with our new programming language. Okay. Vim. Vim parser.c. Where are you? Of course. Fuck. Vim parser.c. Where do I have issues? Where do I have issues? It's here. It's here. Another one. Implicit declaration function. Evaluate operation with your meal. Evaluate. No, I didn't. No, I didn't. Okay, so it seems that this guy needs to be above. Okay, even better. How to move lines in Vim. Okay. So I have visual mode, right? I go down. I cut them. I go above. I paste them. Amazing. Main is normal and non-static function. How the fuck did I mess? I think I'm missing a closing brace here somewhere, right? Yeah, it's here. It's here. It's like this. Control reaches end of non-void function. But it's working, right? It's only a warning. Plus 5 2. Okay. Let's see why this is happening. I think I also need to return 0 here. Is this the reason? Plus 5 2, it's 7. No, it's the segmentation fault. Fuck! Come on, why? What's wrong? Is it this one? I think it's this one. Let me just remove it. Oops. Okay, still a segmentation fault. Okay. Why? So I'm comparing the operator string with the plus. I'm evaluating the abstract search tree here. So I'm looking for the tag. If a tag is a substring of the number, I'm doing this. I'm doing this. While string substring of the children of t of the tag I have no idea why this fails. I mean, I'm not sure this is the issue, but I know it's definitely not this, but okay, it was this. Oh my fucking god. Okay. So now that this shit works, I just want to analyze it. I want to see what I know and what I don't know here. Okay, we have the bonus marks. I think I'll leave them for the next lesson. Write a recursive function to compute the number of leaves, to compute the number of branches. Okay. Oh fuck, I'm so tired. Vim parser.c. Okay. Only this part counts. Let me go line by line. This one is defining the language. Okay. Let's do it line by line. What is the... What does this snippet of code do? Okay. We define a simple language parser using the MPC microparser combination library, which is a C library for building parsers. Okay. The snippet constructs a basic parser for a Lisp like ChatGPT even know that it's a Lisp-like expression language. Let's break down the code. Okay. Parser definition. The code initializes several parser objects. Number, operator, expression, and Lisp. Okay, so these are parser objects. Then we specify the grammar. The MPCA language function defines the grammar of the language using a string containing the grammar rules. So what do we have here? We have two things. The first one, creating parser objects, right? The second thing, creating the language, right? or defining the grammar. Defining the grammar. And we use regex to match rules here. Expression. Okay. So I think I understand this. These are the parser objects. Parser objects. And this here is the language definition. Basically the way we construct the language. We start from a number. The number can be negative and we are using regular expressions. And we are using regular expressions here. Then you have the operator, which can be one of these four characters. Then the expression can be either a number, only a number, or starting with opening braces, it can be an operator plus an expression. Why do we have a plus? Why do I have a plus here? What's the plus doing here? What is the plus doing? Ah, okay. It's the regex. We need one or more expressions that follow the operator. So one or more expressions. And what is the Lisp? It starts with an operator and then has an expression. And the expression can be a number or operator and another expression. And then of course expression can be number or the operator and another expression. Okay. While the loop is running, we created an infinite loop in order to handle input-output methods. What do we have here? We have the result of the parse here, and then if MPC parse. Okay, let me also just check how ChatGPT explains this. Please explain this as well. Okay. So basically the MPC result, it's a structure to store the result of a parsing operation. Okay, now this is what I'm interested in. Oh, okay, it also explains the parameters. So what do we have? We have the standard input string. It's a label used for error reporting. It indicates the source of the input being parsed. In this case, it's labeled as standard input, suggesting that the input comes from standard input. Okay. Ah, okay, this is only useful for debugging. So it's used for error reporting. No idea why. No idea why they put it as the first argument here. We have the input. We have the input. This is the string that we want to parse, and we get it from reading the line, from the readLine method. Yeah, it's typically a string that the user has entered or has been read from the source. This is the parser. It's of type MPC parser T type. And we have a pointer to the result variable. The MPC parse returns either true or false. If the parsing is successful, you can proceed to work with the parsed data. Okay. MPC result T cat MPC H MPC result T. Where are you? Where are you? Ah, here it is. So we have pointer to the error variable and the output. Okay. MPC val P, where is the output? Ah, so MPC vol T, where's the next? Where's the next? It's here. Where is it defined? Where? Oh, fuck. Where are you defined, brother? Ah. Okay. Okay, let's try to debug this. Where the fuck are you? You are here. Will this work? No, it won't. Why? No idea. Maybe I should put it here. Okay. 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 So I have set the debugger properly, and where are we now? And we are here at the start of the eval. Okay, nice. So I can print the tag can I print t? It's a whole structure. Str the tag number. Okay, so it seems that I can't use built-in C methods inside the debugger, most probably. Okay. Print t dot tag. It's this. How is this possible? How is it possible that the language evaluates this character here? It shouldn't do this, right? I think it shouldn't do this. But it does. Why does it evaluate this greater than symbol here? Let's debug it again. Parser. Get the it's GDB parser. Okay. Break eval run. No. Plus 511. It's still this. Why? Okay, I have a couple of lessons that I learned. Seems that initially here, this might be the starting point of the parser. So here we have the plus. The operator is always the second child. Is it? Ah, the operator is always the second child. Okay. I need to quit it here. I'm really sorry. I need to quit the stream. We'll continue. I'm gonna do two things when I come back tomorrow. We're gonna do some more debugging, some more learning about what's happening here, and the second thing is we're gonna solve all of these extra marks. So thank you all for watching. I'm really sorry it's so late. I'm drunk, so I need to make it quits here. But we will continue and we will continue tomorrow. Thank you so much and sayonara.